implicit partial differentiation, an equation g of x and y equals c can, in some cases, not all cases, be solved to give y dash as a function of x dash. For example, if g of x and y is x squared minus y, then the equation g of x equals 0 is x squared minus y equals 0, which gives us y equals x squared. In general, we say that an equation g of x and y equals to 0 defines y implicitly as a function of x if there is a function y of x which satisfies the equation for a range of values of x. Like in our example here, y equals x squared, right?
Mm-hmm. Yes.
Yes, this is y of x equals x squared. So it is often difficult to or impossible to solve the equation g of x and y equals to c and find a formula for y of x. And we wrote this yesterday. Let's see the example. But we can often still find the derivative dy dx even if we don't have an explicit expression for y in terms of x. In fact, dy dx can be found simply in terms of the partial different derivatives of g by the formula dy dx equals minus dg dx divided dg dy.
And this formula for what we use? For what reasons?
For what reason?
Yes.
The derivative gives us the maximum and minimum and so on. And when the function is increasing, when the function is decreasing. We studied this before. And this
okay.
really. So this is the rule we are working in with, which is dy divided dx equals minus dg dx divided dg dy.
Okay.
Example. Suppose a quantity y is defined as a function of x through the equation, this equation, equals to 0. X squared y cubed minus 6x cubed y squared plus 2xy equals 1. Let's find a general expression for the derivative dy dx, the equation defining y implicitly as a function of x is of the form g of x y equals 1, where g dash, this is g of x y, equals the function, this function.
Okay.
X squared y cubed minus 6x cubed y squared plus 2xy without the 1. We didn't try the 1. So you will find from here dg dx and dg dy, and divide this by this, right? Dg dx divided dg dy, but with minus sign, with negative sign. So we need now to calculate what is dg dx is what from here. The derivative of g with respect to x. Here we have x squared, right?
Mm-hmm.
What is the derivative of x squared?
2x
2x and y
cubed,
cubed
y cubed, yeah.
minus this is
Minus 18x squared, y squared,
plus
plus 2y.
and dg dy is with respect to y.
So it would be x squared 3y squared, or 3x squared y squared, minus 12 x cubed y,
Yes,
plus 2x.
right. Okay. Now you will divide this by this, right?
Yes. But Ustaz, what's the reason for dividing like, what's the reason dividing these two?
We need to calculate dy dx. We need to find, let's find a general expression for the derivative dy dx.
But we already found it through derivative, yes?
Derivative of what? We don't have direct derivative. We need to, we can get dg dx and dg dy, but we need dy dx.
Okay, right now it's clear.
So here dy dx is negative dg dx divided dg dy.
Right now I understood, yes, okay.
Yes. And he calculated this, right, like we did, and calculated this like we did, I think. Yes. And this is right, yes. Now, dy dx is negative, this negative. So now we need to find, I write it in green color. So dy dx is negative dy, I'm sorry, dg dy divided dg dx. This is the rule, right?
Yes.
So negative this is not the rule. The rule is dg dx 4. This is dg dx, right?
Yes.
This is dg dx. So negative what? Negative this 2xy cubed minus 18 x squared y squared plus 2y, right? Divided 3x squared y squared minus 12 x cubed y plus 2x, right?
Yes.
So the negative sign, I will multiply negative sign here and here and here, right? So the result will be, you can say positive 18 positive 18x squared y, and this will be minus 2xy cubed, and this will be minus 2y, right? Divided this 3x squared y squared plus 2x cubed y plus 2x, and this is the answer. Okay? Hello,
Okay.
are you here?
Yes.
This is the answer, 18x squared y squared, like we write, I think, minus 2x y cubed minus 2y divided 3x squared y squared minus 12. There is minus 12 here. This is minus 12, minus 12, yes. This is minus 12. This is minus 12. Minus 12. And this is 1, no, plus 2x, right?
Yes.
Suppose we wanted to calculate this derivative when x equals 1/2. So we will substitute x equals 1/2. We first need to find the corresponding value of y. So at x equals 1/2, what is the value of y? We will calculate it, putting x equals 1/2 into the defining equation, x squared y cubed minus 6x cubed y squared plus 2xy equals 1.
Yes.
So x squared is 1/2 squared y cubed minus 6 multiply 1/2 cubed y squared plus 2 1/2 y equals 1. So
it would be 1/2 multiply 1/2. It would be
1 over 4 y cubed minus
6
x
1.
over 8.
Yes, y squared plus
Y.
It's a 1. Just 1.
Y. 1y, yeah.
Yes.
1y equals 1.
Yes.
So this is, we will multiply all this by 4. Because this is 3 over 4. This is divided 2 equals 3, divided 2 equals 4. So when we multiply by 4, the 4 we will multiply it here and here and here and here. So this is 4 multiply 1 over 4 is y cubed.
Yes.
Minus 3y squared plus 4y, and this one will be 4, and will come to the other side, will be minus 4 equals to 0.
And here we have a quadratic equation, yes?
No, this is not quadratic, this is cubic equation.
Yes.
Third grade equation, and we will factorize by grouping. We will take common factor here, y squared, and we have here y minus 3 plus, we will take 4 here, common factor, by grouping. He did this. No, by grouping is not going to make us any help.
But Ustaz, for example,
yes,
can we use a cubic equation, like cubic rule, for solving this problem, or factorizing is a better way? What would you recommend in this case? Or it's possible, for example, to use each of them.
Factoring this can be factorized by, I think, by calculator or by rule. There is a rule
Mm.
So this is like here, this is we can revise the rule of factoring cubic function. But here this is a minus b multiply a squared minus, and this is, I don't know but the factoring of cubic equation is not that easy
Yes, I
in
know.
cubic equation. So now let's take it like this. Y minus 2, y squared minus y plus 2 equals to 0. So
Okay.
these are the roots. We have 3 roots here. 3 roots, or this is y equals 2 here. Y equals 2. At x equals to 1, at x equals to 1/2, y equals to 2. Because the other roots is imaginary roots. So he substituted at the other page here in this equation, and he put x equals 1/2 and y equals 2, and this is answer.
Mm-hmm.
6. Let's try it. We'll do it. Okay. So
Yes.
at x equals 1/2, y equals 2. So we'll substitute here. يبقى dy dx equals 18, x squared, which is 1/4, y squared is 4, right?
Yes.
Minus 2x is 1/2, y cubed is 8, minus 2y is 2, divided 3, x squared is 1/4, y squared is 4. Are you with me?
Yes, and here I'm following you.
X cubed is 1/8, y is 2, plus 2, and x is 1/2, right?
Yes.
Now, 2 with 2, 1, 1. So this is 1, this is 1, 2, and this is 1, divided 4, and this is divided 4 is 1. And this is divided 2, 4, 1, divided 4, 1, 3. Any other factorization? Simplifying, I'm sorry. So this is 18,
18
minus
8
minus
4. Then
divided
3. Then 3 plus 1.
minus 3 plus 1. So
Here we have
this is 0.
it would be 6 over just 6.
6/1 is 6. This is the answer,
Yes.
which is dy divided dx. Suppose the G of x, y, z equals C defines z implicitly as a function of x and y, then dz dx equals minus dg dx divided dg dz, and dz dy equals negative dg minus dg dy divided dg dz. This is the same, but he didn't give us any example for this.
Mhm.
Maybe in the file, this file
Yes,
thing.
or examples, yes, for solving. Should be, yes.
Functions of several variables. Activity 5.1. What sort of service do you think is described by the equation that z equals root x squared plus y squared? What do you think?
Mm, I just didn't really understand the question. What does it mean? What sort of surface?
Like service of cubic or sphere or
Quadratic, yes.
cone or cylinder or curve, just curve or arc. Yani arc, cylinder, cone, sphere, cube, and so on. Okay.
Yes.
So this is z equals root x squared plus y squared. This root, this curve will be. Okay, check it.
There is root x squared plus
What root? How can we write root?
you can write in power 1/2. Or is it possible to copy that equation from a file?
This is a sphere here, x squared plus y squared plus z squared equals b squared. This is a sphere.
But to be honest,
Yes.
how, for example, in my case, can I identify whether it's sphere or something else?
We will know it. We'll know it. Like this. We will know that this is paraboloids. surfaces whose intersections with planes perpendicular to any two of the coordinate axes are parabolas. In those planes are called paraboloids. Paraboloids. An example is shown in the figure below. This is the graph. So in our case, we have here z equals root x squared plus y squared. This is not our case, but this is not our case. Now, hyper can you pronounce this? Hyperboloids. And this is not our case too. If we have here x squared plus y squared, let's say minus z squared equals 0. So this z squared equals what? X squared plus y squared, right?
Yes.
So z equals root x squared plus y squared, right?
Yes.
So here, this is x squared minus y squared minus z squared. This is not our case too. And y equals z squared. Cylinder. This is cylinder, which is y squared plus x squared plus y squared equals 16. Or any number. And this is I don't know where is the answer of your question.
Okay, we can live with that.
Yes, okay. Let f of xy equals x squared y plus 5xy cubed plus y squared. Find the partial derivatives of f. What is the partial derivative?
Partial derivatives.
Yes, partial derivative is df dy or dx and df dy, right?
Mm-hmm. Yes.
The derivative of this function with respect to x is what?
With respect to x, it would be 2xy
Yes,
plus 5y cubed.
yes,
Nothing.
yes. And df dy?
Here it would be 2xy, or no, just 2x squared.
X squared, just x squared, because the derivative of y is 1.
Yes, just x squared plus 15xy squared plus 2y.
Right, that's it. Easy, I think, very easy.
Yes,
What do you think?
quite, yes.
Right. Suppose f of x, y equals x cubed y minus x over y. Find the partial derivative of x.
So also we need to start with finding a derivative with respect to x and y, yes? So here then it would be 3x y.
X squared?
Yeah, squared y minus ln x.
No, derivative of x is 1. Right? With respect to x, derivative of x is 1. 1 over y.
Oh,
Okay?
that, yes.
Right. df dy is
Here we have 3x. No. X cubed minus x over 1 or minus x.
x. Derivative of 1 over x is of y is what?
It's just x. Because y in denominator and it would be just x. Yes?
No. Derivative of 1 over x integration using derivative integration.
Ln, but I'm not sure.
Yes, might be ln, yes. Curve differentiation. AX x power negative 2 بقى. Derivative of ln x is 1 over x. Derivative of x power n is x power n minus 1 multiply n. So in our case, where is, I think here, the derivative of 1 over y is y power negative 2 multiply negative 1. يعني -1 multiply y power -2. So this is x cubed plus x over y squared, right?
Yes, yes, right.
Now z equals f of x and y equals x squared y plus y cubed x. Find second order partial derivatives. Second order partial derivatives. So
Order, it's like second derivatives. Yes, we found first derivative and we found second derivative. It's the
yes,
same,
df dx is what?
So it would be 2xy plus y cube.
So here we can have d2f divided dx squared and d2f divided dx dy. So what is this? So we will take this, the derivative of this with respect to x again. With respect to x.
With respect to x, it would be 2y.
Yes.
And just 2y. Yes, and
with respect to y back.
And here it would be 2x plus 3y squared.
So these are the second derivative.
Yes.
This one and this one.
So it's second order derivative, yes?
This is the second derivative, yes.
Okay.
And we have another second derivative. df dy. So we will take the derivative of this with respect to y. What's the answer?
The derivative of this with respect to y, then it would be 6y.
Where is 6? Here.
This one. This one, it would be just x squared plus 3y squared x.
So now we have two ways, d2f dy squared and d2f dy dx. This with respect to y. Derivative of this with respect to y.
So it would be just 6yx.
xyx.
This would be 2x plus 3y squared.
With respect to y, 6y. 6yx, right?
6yx. I thought we don't change.
No, with respect to what? Now, the other one with respect to x, I'm sorry, this is wrong. With respect to x here, so this is, the derivative of x is 1, so this is 3y squared, right?
Yes.
That's it. So this is the second derivative, and this is the second derivative. We have here 4 second derivatives. This is number 1, number 2, number 3, number 4. And we have this and this are equal.
Okay.
Right?
Yes.
I find the second order derivatives of the function f of x y equals x cubed.
Okay, so here it would be the same. We find first of all derivative of with respect to x and with respect to y.
Yes.
3x squared y minus 1 over y.
d2f dx squared and d2f dx dy.
Here we have 6xy,
Mhm.
and here we have 3x squared minus just 3x squared.
بصي minus y 1 over y is equal to minus y power negative 1. So this will be minus 1 multiply y power negative 2. So this is will be positive y power negative 2, which is 1 over y squared. Okay. The derivative of this, let's say this is z, so this is z derivative. Okay.
Yes, okay.
So what is the derivative of negative 1 over y is? Positive 1 over y squared.
Yes.
We just did it here. Negative 1 over y is negative 1 y power negative 1. What is the derivative of y power negative 1? Is negative 1 multiply y, and we take or subtract 1 from the power. So minus 1 is minus 2. Minus 1 multiply minus 1 is positive 1, y power negative 2, which is 1 over y power 2. Okay?
Yes.
Right. df dy. This is the first derivative. Here, this is the first derivative, right?
Yes.
And this is the second derivative, right?
Yes.
So we will take this, we will make the derivative of this with respect to y. The
It
answer?
would 3x cube. No, just x cube minus just x cube. Yes.
Minus here, this is x over y. With respect to y, again, the 1 over y will, what is 1 over y? The derivative of minus 1 over y is positive 1 over y squared. So this is 1 positive x over y squared. Because this is the derivative of 1 over y or x over y with respect to y, like here, like this here, this part.
Okay. Yes. Okay. Understood.
Right. Now we will take the derivative d2f dy squared again with respect to y.
It would be just 1 over y.
This is again, this is 1 over y squared, which is y over negative 2. Y power negative 2. The derivative of this, let's say this is t, so t derivative is what? Negative 2y power negative 3, which is negative 2 over y power 3.
So it would be just negative 2 or y over y power 3.
Negative 2x over y power 3. Because we have here x.
Yes.
d2f dy dx is what? Shukran.
Okay. Here, with respect to x, yes?
Yes.
Then it would be 3x squared. Just it?
Derivative of x is 1.
Is 1? Oh,
yes.
Okay.
1. يبقى 1 over x, 1 over y squared. right?
Yes.
So, and we can see that this is like this.
Yes.
And when in the explanation or notes, the teacher or doctor, professor said that this is true in our cases, our studies, but this is not true in all cases. But we will study just so d2f divided dx dy is like d2f divided dy dx.
Okay.
Okay.
Yes.
Find all the partial derivatives of and second order partial derivatives of the function, this one. F of x and y equals x cubed, x power 3 over 4 multiply y power 1 over 4.
Well, here.
df dx.
So it would be 3 over 4 multiply x minus 1, it would be minus 1 over 4 or y more power 1 over 4. And we can write it's actually like, can we write minus negative 4 in denominator?
Negative 1 over 4, you want to write it like this. You want to write it like this,
I
x
mean,
power
like
1 over 4.
here we have x in negative power. And I think no, I'm just asking.
Yani,
Yes,
but this is
use as we did.
Yes, but this is easier for us to make to take the derivative. This form is better for derivatives. Now we will take the derivative again with respect to x again.
With respect to x, then it would be negative, so it would be negative 3 over 4 multiply over 4, it would be a negative 3 over 4.
Over 16.
X.
Over 16.
Yes, sorry. Yes, I was. So yes, 3 over 16 multiply x positive 3 over 4.
Not positive, this is negative. We will subtract 1. So this is minus 4 over 5 over 4.
Yes. Okay.
So this is minus 3 over 16, x power 5 minus 5 over 4, y power 1 over 4. Now what? We'll take the derivative with respect to y. Hello?
Yes, I'm thinking. So here we can write as 3 over 4 x power negative 1 over 4, where we can write as 3 over 4 multiply 1 over 4. 1 over 4, yes. We take y, and minus 1 would be negative 3 over 4, power negative 3 over 4.
So the answer is 3 over 16, x power negative 1 over 4, multiply y power negative 3 over 4. So now, df dy. The first derivative of this function is what? With respect to y.
With respect to y, it would be x power 3 over 4 multiply 1 over 4. Yes.
Yes.
Or we can write 1 over 4 before, like the first. Yes.
Mhm.
1 over 4 x power 3 over 4 y power negative 3 over 4.
Right.
Yes.
Yes. Second derivative with respect to y again, and with respect to x.
It would be, so the first it would be 1 over 4 x power 3 over 4 multiply negative 3 over 4. So we can write actually like negative 3 over 4 16 as negative
Yes.
3 over 16, or we can write as here, right? Okay, so it would be negative 7 over 4. Or yes?
Yes.
Y power negative 7 over 4.
Yes. Now, second one, with respect to x, this with respect to
And
x.
here we can write as 3 over 16. It would be 3 over 16.
Yes.
3 over 16.
Mm.
X power negative 1 over 4.
Mm-hmm.
Multiply y power negative 3 over 4.
Yes. And we can see that this is equal to this. These are equal, right?
Mm-hmm.
Again, suppose that f of x, y equals x squared y, and that xt equals 2 plus 3t and yt equals t squared plus 1. If f of t equals f of x t yt, يعني f of x of t and y of t, find the derivative of df dt.
Mm-hmm.
This is another thing. Do you remember the rule of this? df dt equals what?
What exactly? I don't remember, to be honest.
We can find it by two ways.
Mm-hmm.
By substitution and by making the where is the rule? We can revise the rule. The rule is here. This is the rule. df, you can write it here. df of dt equals df over dx multiply dx over dt plus df over dy multiply df dy. dy, I'm sorry. dy dt. This is the rule, our rule. Chain rule.
Yes, okay.
Now we can solve. We'll use this rule and solve. What is df dx? Is what?
df dx.
We will take df dx from here.
Yes.
The derivative of this with respect to x is
Also 2xy.
yes. And what is dx dt?
With
Take
respect
this from here with respect to t from here.
so 2 plus 3.
No, 2 is constant. The derivative of constant is 0.
Okay,
With
so
respect to t,
it will be just 3.
and df dy is, we'll take from here again,
Yes.
with respect to y.
So it would be x squared.
And dy dt.
Yes. It would be 2t. Yes.
So let's substitute df dt is this one, which is
it would be 2xy
multiply this one,
multiply 3
and this plus
squared plus multiply 2t. And here we have 6xy plus 2x squared t.
we will substitute
How?
x equals from here 2 plus 3t, and y equals from here t squared plus 1 here. So df dt is what? 6. X is what? 2 plus 3t, right?
Yes.
And y is t squared plus 1 plus 2. X squared is what? From here, 2 plus 3t, right? Squared. Multiply t, right?
That's right.
So now we will make FOIL here. FOIL, first times first. And first outer, وبعدين inner, last. And this will multiply 2t here and here. So the 6 is multiplied by 2t squared plus 2 plus 3t cubed plus 3t, right? Plus 2t multiplied 2 is 4t plus 2t multiply 3 is 6t cubed. So this 6, we will multiply this 6 here, and here, and here, and here.
So then we have 12t squared plus 12 plus 18t cubed.
Yes, 12t squared plus 12 plus 18t cubed plus 18t plus 4t plus 6t cubed, right?
Yes.
So what is the final answer? T cubed and 6 cubed, this is 18 and 6 is 24 t cubed.
Plus 12t squared plus 22t and plus 12.
Thank you. This is the final answer. Right?
Yeah. Yes.
And we can make another way to solve this, I think.
Okay.
If xy equals x squared y. So this is x squared. What is x squared? X squared is 2 plus 3t squared, right?
Yes.
Y is t squared plus 1.
Yes.
So this is 2 plus 3t squared. We can make it like this, right?
Yes, right.
So now we'll make a FOIL. First, بعدين outer, بعدين then inner, then last. 2 times 2 is 4. 2 times 3t is 6t, right?
Yes,
3t times 2 is 6t again. And 3t times 3t is 9t squared. Multiply t squared plus 1. So this is 4 plus 12t plus 9t squared multiply t squared plus 1. So again, we will multiply this t squared here and t squared here and t squared here and 1 here, 1 here, 1 here.
Here we have 4t squared plus 4.
Yes.
Plus 12t cubed.
12t.
12t, yes, sorry. Plus 9t4 plus 9t squared. Yes.
So we can add, we have here 9t power 4 and 12t cubed, and this is 13t squared, and this is 4, just 4.
Yes.
df dt is, this will be 36t cubed plus 36t squared, right?
Yes, right.
Plus 26t and 0.
Yes.
Something wrong.
Why?
This is not the answer, what we did before. Something wrong. X squared y, and this is 2 plus 3t y, t squared plus 1. This is 4 plus 12 t plus 9 t squared, 4 t squared plus 4 plus 12t cubed plus 12t. 4t, 9t cubed, 4, 12t cubed, 13t squared. Where is 13t squared? 13t squared is, yes, plus 4. The derivative is 36t cubed plus 36t squared plus 26t.
You wanna find yes or what's
d of x dx and d of x dt, d of x, df dy, dy dt. df dx is 2xy, yes. dx dt is 3. df dy is x squared. dy dt is 2t. We'll multiply this, 2xy multiply 3. So this is 6xy, yes. Plus x squared multiplied with t is 2x squared t. Substitute x equals 2 plus 3 and y equals t squared plus 1. So this is 6 multiplied 2 plus 3t squared plus 1.